June 16, 1944, Asen Point, western Guam. The first rays of the Pacific sun bled across the shattered coastline, revealing silhouettes of men crouched behind crushed coral mounds. The surf pounded with a deep, rhythmic growl, carrying the stench of salt, fuel, and spent cordite. Machine guns rattled from the tree line, stitching the beach with bursts that kicked up white fountains of sand. And in the middle of it all, far from the infantry lines where such chaos was expected, stood men holding shovels, graders, and surveying rods instead of rifles. Their blue denim uniforms clung to sweat-slicked backs. Their helmets rang with the sting of ricochets. These were the U.S. Navy construction battalions, the Seabees, arriving to build an airstrip in the middle of an active killing ground. A Marine captain watching the beach later noted in his field log that the builders moved with the calm of men repairing a road back home, even as Japanese Nambu fire ripped into bulldozer armor just meters away. The Seabees bulldozers, many fitted with improvised steel plates welded by stateside engineers under Rush Naval Bureau of Yards and Docks directives, groaned forward like lumbering giants, engines roaring against mud and coral. Each machine was a target, every operator exposed. Yet the order was simple. The airstrip must be operational within days, not weeks. 24 liberators needed a forward base. Casualties elsewhere depended on it. The Japanese defenders watching from hillside bunkers couldn't understand what they were seeing. According to a post-war intelligence summary that quoted captured diaries, several officers wrote that the Americans sent construction men instead of soldiers, convinced it was desperation or a trick. But the truth was the opposite. Admiral Chester Nimitz had learned through bitter experience on Tarawa and the Marshall Islands that victory in the Pacific hinged on accelerating logistics, airfields, roads, fuel depots, and the Seabees were now considered as crucial as the Marines they landed beside. Time measured in hours determined who controlled the skies, and Japanese observers were watching the impossible unfold in front of them. The context behind this moment stretched deep into the war's industrial heart. By mid-1944, the United States had deployed over 250,000 Seabees across every major theater, supported by stateside institutions like the Naval Construction Training Center at Camp Endicott. Engineers such as Rear Admiral Ben Morrill, often called the father of the Seabees, had pushed for a force of technically skilled builders who could fight and construct simultaneously. Their mandate was simple but revolutionary. Land with the first waves, build under fire, keep building even if the battlefield shifted around them. In contrast, Japanese engineering units operated on traditional models, relying on manual labor, wooden tools, and local conscripts who often lacked machinery or training. This doctrinal mismatch would become increasingly fatal as American offensive tempo accelerated. On Guam that morning, the mismatch was already visible. Japanese commanders had prepared for infantry assaults and naval bombardment, but not for bulldozers charging headlong into machine gun arcs. A Marine platoon noted in a situational report that the enemy kept redirecting fire toward the construction vehicles, confused why the Americans risked them so early. What they couldn't see from their bunker slits was a strategic logic that had been drilled into Seabee operations. Control the ground by transforming it. An airstrip was not just a runway. It was a guarantee that the next wave of combat power would arrive faster than the enemy could respond. The men working the coral fields knew this. Many had been civilian tradesmen, carpenters, welders, surveyors, before joining the battalions. Their hands knew how to measure driftwood angles, weld trusses, level ground. But on Guam, these same hands shoveled dirt while mortars whistled overhead. A grader operator named Paul Hackman later recounted to a naval interviewer that he kept one eye on the blade and one eye on the muzzle flashes and hills. His story echoed countless others. Men improvising under pressure, relying on training hammered into them by engineers stateside, who understood that combat construction demanded instinct more than diagrams. The broader campaign added another layer of tension. Guam was not an isolated objective. It was part of Operation Forager, the massive push across the Marianas that would place American bombers within striking distance of Japan's industrial core. Saipan and Tinian had already witnessed brutal fighting. Casualties on both sides were staggering. The U.S. Joint Chiefs insisted that once Guam fell, its airfields must come online quickly to ease pressure on Saipan's overburdened strips. Every day gain meant fewer B-29 losses. Every hour mattered. As the Seabees hacked into the coral, naval gunfire thundered overhead, shaking the earth in dull, rolling booms. Smoke drifted across the battlefield, mixing with diesel fumes. Communication teams struggled to maintain radio clarity as static crackled through handsets. Yet despite the chaos, progress continued. Engineers in distant Washington had designed these operations to survive the unpredictable. Construction orders were broken into modular tasks, allowing teams to work around interruptions. Even under fire, the blueprint held. Enemy fire intensified as Japanese troops realized the runway formation was not a diversion, but the core of the American plan. A captured-after-action notebook later described this moment with disbelief. The enemy builds airfields faster than we can destroy them. From hillside gun nests, gunners watched bulldozers advance through curtains of smoke, pushing coral like snowdrifts while Marines screened their flanks. The psychological weight of witnessing construction in the midst of combat began to unsettle defenders who had expected a conventional firefight. As the first segment of the runway took shape, the scale of the task ahead loomed like a shadow across the beach. The Seabees still had miles of grading to complete, hundreds of tons of coral to crush, and drainage systems to carve through terrain that fought them every step. Each machine that broke down under strain had to be patched together with field repairs, something made possible only because stateside engineers had insisted on rugged, modular designs to withstand Pacific heat, salt, and shrapnel. Yet, despite everything, progress continued at a pace that defied battlefield logic. Reports sent to the Pacific Fleet stated that runway definition was visible by mid-afternoon, astonishing given the shelling that had never fully ceased. It was in these reports that commanders began to recognize the deeper truth. The Seabees weren't simply surviving under fire. They were reshaping the battle faster than enemy fire could stop them. By sunset, the coral strip stretched like a pale scar across the battlefield, illuminated by the dying orange glow of the horizon. Smoke drifted in ragged sheets over the half-complete runway. The men were exhausted, scorched by the sun, shaken by near misses, but they had built the first stage of a lifeline. And just as they caught their breath, fresh orders crackled through radios, delivered with the urgency of a ticking clock. The Japanese defenders still didn't know it. But what came next will reveal the real secret behind how these builders turned the tide of entire campaigns. 0600 hours, June 18, 1944. 2 days after Ace Point had seen coral shredded under machine gun fire, the Seabees' secret weapon was about to assert itself fully. Speed, precision, and ingenuity born from a marriage of engineering and combat. What looked like ordinary bulldozers, graders, and dump trucks were, in fact, the culmination of months of design work at the Naval Construction Battalion's Engineering Division in Port Hueneme, California. Each Caterpillar D7, retrofitted with reinforced steel plating and quick-change hydraulics by the inventive hands of Chief Engineer Bill Matthews and his Detroit Arsenal team, could push tons of coral in a fraction of the time a Japanese laborer with a pick could manage. On Guam, this engineering edge became a battlefield revelation. Japanese observers, peering through binoculars from hillside foxholes, noted with growing panic that American construction men moved as if untouched by bullets. The mechanics behind this motion were not magic. They were meticulous planning, rigorous training, and a focus on operational redundancy. Each vehicle carried spare belts, fuel lines, and even a small arsenal of defensive implements to keep the machines running under fire. What set the Seabees apart wasn't just armored bulldozers. It was their network approach to construction. Using FM radios designed by Motorola engineers in Chicago, teams coordinated with precision. Supervisors on the beach relayed instructions to graders inland. Supply boats timed deliveries to match shifts in tide and incoming fire. The radios, operating on frequencies between 30 and 50 megahertz, offer a range up to 5 miles under ideal conditions, a range that proved crucial in dense jungle terrain. Japanese snipers and machine gunners, trained to disrupt infantry lines, had no method to interrupt these coordinated movements. When one grader stalled, another shifted position without orders. It was as if the machines themselves thought in concert, a phenomenon later described in Marine after-action interviews as ghosts of iron and sweat. The decisive moment that revealed the Seabees' hidden advantage came during the Battle of Agate Ridge, a few miles south of the Asen landings. Intelligence reports from naval sources indicated that Japanese forces had consolidated artillery along high ground overlooking the planned airstrip, intending to reduce American construction teams to rubble. Yet by dawn, the Seabees were already laying down perforated steel planking over coral fill, a technique pioneered by engineer Charles H. Pratt at the U.S. Navy's Bureau of Yards and Docks. Each panel, weighing 100 pounds and capable of supporting the weight of fully loaded C-47s, was snapped into place by teams working in synchronization. Enemy reports described the scene as impossible, men moving earth and steel faster than our guns can reach. The battle unfolded like a clockwork sequence. Marines laid suppressive fire from the ridges while Seabee teams advanced in staggered columns, bulldozers crushing obstacles, graders smoothing surfaces, and dump trucks delivering crushed coral from supply points 5 miles inland. Each unit had redundancy built into its operation. Spare bulldozers, maintained by mechanics who had been trained by Detroit Arsenal and General Electric engineers, rotated to ensure constant movement. Radio operators relayed real-time updates to headquarters, enabling commanders to adjust priorities without halting progress. Japanese mortars fell short or overextended, a combination of miscalculated trajectories and the rapid pace of construction. By mid-afternoon, the first 1,200-foot segment of the airstrip was complete, capable of supporting liaison planes even as battle raged around it. Technical specifications underscored the ingenuity. Bulldozers weighed 24,000 pounds, with reinforced armor plating up to 1.25 inches thick at vulnerable points. Graders with 14-foot blades could level uneven coral surfaces in minutes. The perforated steel mats, 10 feet long and 3 feet wide, distributed the weight of AC-47 over 100 square feet, preventing ruts that could ground aircraft. Trucks carried up to 5 tons of coral per run, engineered to handle the mud-slick slopes and tidal flats unique to Pacific Islands. The combined effect was a synchronized ballet of metal, dirt, and human ingenuity, executed under conditions that would have paralyzed conventional engineers. Japanese commanders, meanwhile, struggled to comprehend the transformation. Intercepted signals and captured diaries later revealed their disbelief. They build as they fight faster than we can destroy. This frustration was compounded by an inability to target specific vulnerabilities. The Seabees vehicles could rotate axes, lift, and reposition on the fly, and when one bulldozer took a hit, another shifted forward without breaking tempo. Air reconnaissance reports confirmed the pace. What was projected to take 10 days was achieved in under 72 hours. The human element amplified this advantage. Each Seabee carried the dual burden of construction and defense. Teams practiced offensive drills as part of daily routines, ensuring that while one unit leveled a runway, others could repel infiltration. This dual training regimen was conceptualized by Lieutenant Commander John R. Brooke, whose protocols merged civilian construction efficiency with Marine combat drills. Morale played a subtle yet crucial role. As one corporal later recounted, "We knew our work wasn't just gravel and steel. It was a lifeline for the boys still fighting inland. Every shovel, every mat, every bolt mattered." By the third day, the airstrip extended more than 2,000 feet inland, a staggering feat considering terrain, enemy fire, and supply limitations. The Japanese, observing from the ridge, were bewildered. Artillery strikes that had shredded infantry waves seemed ineffective against the moving tide of machines and men. Captured communications revealed confusion and despair. They are not soldiers, yet they advance faster than bullets. They are not engineers, yet they create airfields under fire. The Seabees' innovation had created a battlefield paradox, a non-combat unit performing the function of both engineer and frontline soldier, redefining conventional expectations. The impact of the secret advantage rippled beyond Guam. Naval planners took note of the speed, equipment specifications, and operational doctrine, realizing that this combination of armored machinery, rapid deployment, and technical precision could tilt campaigns across the Pacific. The Agate Ridge operation became a case study in military engineering, lessons in redundancy, field repairs, and combined arms coordination that influenced subsequent landings at Peleliu, Iwo Jima, and Okinawa. It demonstrated that industrial ingenuity, tractors, steel mats, radios, could determine outcomes as decisively as infantry tactics. Even as the sun dipped below the horizon on June 18th, the Seabees were far from finished. Supply lines hummed with fuel and materials. Bulldozers were repaired, and the next segment of the airstrip awaited construction. From the ridge, Japanese troops watched the surreal scene unfold. Men building as they fought, machines advancing under fire, a controlled chaos that seemed impossible. The seeds of tactical and technological dominance were planted, and soon the world would witness how these builders would not just support war, they would shape its course. And while the Japanese could only guess at what made it all possible, the truth lay in a combination of design genius, relentless labor, and disciplined coordination, a secret that would soon redefine the entire Pacific campaign. The question now loomed over every officer and enlisted man on Guam. If the Seabees could construct under fire, what would happen when their airstrip was completed and fully operational? The answer would come in Section 3, revealing the strategic and psychological ripples of this unprecedented advantage. 0600 hours, June 21st, 1944. 3 days after the final panels of perforated steel were locked into place at Asen Point, the Seabees airstrip roared to life. From above, B. 24 Liberators lumbered down the newly flattened runway, engines screaming as if announcing a new era in the Pacific. What had begun as a precarious construction operation had now become a linchpin of strategic dominance, and the ripple effects extended far beyond the island. Allied commanders recognized immediately that the ability to construct functional airfields under fire was not merely a tactical advantage. It was a psychological weapon that unsettled Japanese forces and reshaped operational planning across the Marianas. The impact was first felt in enemy morale. Japanese defenders, already battered by relentless artillery and amphibious assaults, found their efforts increasingly futile. Interrogations conducted post-war revealed a common theme. Captured officers consistently described an almost surreal fear of the Seabees' efficiency. "They do not fight like men," one officer noted. "They do not build like men. They are a force of nature that moves with the tides of war." The combination of armored machinery, disciplined crews, and innovative construction techniques forced Japanese units to divert artillery, manpower, and planning toward a problem they could not solve, a runway that appeared impervious to conventional attacks. Every effort to shell or impede the construction simply accelerated Allied adaptation. Field repairs were implemented immediately, and forward reconnaissance identified vulnerable points before the enemy could act. For the Allies, the psychological effect was equally profound, but in the opposite direction. Marines, infantry units, and pilots alike drew confidence from the knowledge that reinforcements, supplies, and close air support could arrive with unprecedented speed. The airstrip became a tangible manifestation of industrial ingenuity and human resolve. Admiral Nimitz's dispatches from the Pacific Fleet headquarters highlight this. He described the operation as a demonstration of American resolve and ingenuity, where steel, sweat, and courage combined to bend the battlefield to our will. The pride of witnessing construction under fire translated directly into increased combat effectiveness across units, reinforcing the broader doctrine that logistics, often overlooked, could dictate the tempo of war. The Seabees themselves became legendary within weeks. Their contribution was no longer merely auxiliary. It had become operationally decisive. Engineers who remained stateside, coordinating supply chains and designing modular, reparable equipment, were credited in after-action reports for ensuring every bulldozer, grader, and truck could sustain relentless operations under tropical conditions. Factories in Detroit and Cleveland, along with designers at the Bureau of Yards and Docks, had anticipated issues ranging from hydraulic failures to tropical corrosion. This foresight allowed field units to continue construction with minimal downtime, illustrating a profound synergy between industrial design and frontline execution. Each repair, each improvised modification, each innovative use of steel matting extended the psychological and strategic advantage across the battlefield. The strategic ramifications were immediate and far-reaching. Guam's airstrip allowed for rapid deployment of aircraft to support ongoing operations on Saipan and Tinian. Reconnaissance missions could be flown with greater frequency, mapping Japanese troop movements and enabling more precise bombardments. The presence of operational airfields within striking distance of the Japanese homeland shifted the operational calculus, forcing enemy planners to divert resources to defend locations previously considered secure. The speed with which the Seabees had transformed coral beaches into fully operational airstrips accelerated the Allied timetable for invasion and subsequent logistical buildup, fundamentally altering the campaign's momentum. But the human cost was ever present. Seabees, though shielded by improvised armor, faced shrapnel, heat stroke, and psychological strain. Field medics noted cases of acute exhaustion, while mental health reports later documented the unique stress of building under fire. Despite these hardships, the collective discipline and technical training allowed for sustained operations. Each unit functioned with redundancy. Mechanics rotated, supply chains were optimized, and teams could replace lost personnel without halting progress. This operational resilience became a defining feature of the Seabees' legacy, demonstrating that human ingenuity and rigorous planning could match or exceed traditional combat power in shaping battlefield outcomes. The psychological pressure on the Japanese extended into the post-capture analysis of the Marianas Campaign. Prisoners of war and intercepted communications reflected an enduring fear that no matter how entrenched they were, the Americans could construct, adapt, and strike faster than defenses could respond. The realization of this ability to build under fire affected Japanese doctrine, leading to increasingly conservative defensive strategies and avoidance of direct confrontation whenever possible. In this sense, the Seabees' work was as much a psychological weapon as a physical one, shaping decisions from Tokyo to the front lines and undermining morale at every echelon. The legacy of this innovation carried into the post-war era. Lessons learned in Guam influenced Cold War engineering, rapid deployment logistics, and even modern network-centric operations. Military academies incorporated Seabee doctrine into curricula, emphasizing the interplay between engineering, logistics, and combat effectiveness. The concept of modular, resilient, and rapid deployment construction units became standard, informing everything from airfield repair in Korea to modern expeditionary operations in Iraq and Afghanistan. Engineers, technicians, and planners recognized that the seeds planted in coral and sweat on Pacific beaches had grown into a universal doctrine. Infrastructure can be a weapon as powerful as artillery when executed under duress. Technological innovation and human courage merged seamlessly during these campaigns. The improvisation of armored bulldozers, the precision of FM radio coordination, and the relentless work ethic of the Seabees created a template for operational dominance. Maintenance cycles, field fixes, and continuous feedback loops between engineers and operators ensured that even under extreme duress, operations continued unbroken. The psychological effect of witnessing such resilience on both allies and enemies reverberated far beyond Guam. Veterans recalled that every completed meter of runway instilled confidence that no obstacle, no matter how lethal, could halt the American advance. By the end of June, Guam's airstrip was not only functional, but strategically transformative. Air support could be deployed within hours. Supplies flowed with unprecedented reliability, and a combined effect of speed, technical precision, and human determination forced Japanese commanders to reevaluate what was possible in warfare. The Seabees, once regarded as mere builders, had become architects of victory, their legacy enshrined in steel, coral, and the collective memory of the Pacific theater. As one post-war Marine reflection captured it, "We thought we fought alongside soldiers, but it was the builders who won the day, hammering history into the earth with every steel plate and every measured yard coral." From a roar of engines on Guam to strategic doctrines of modern militaries, the lesson endured. Ingenuity, courage, and disciplined execution under fire could rewrite the rules of war. The Seabees had proven that the line between construction and combat was not just blurred. It was a battlefield advantage in its purest, most lethal form. And so, from the mud, coral, and smoke of Asen Point, the builders forged more than an airstrip. They forged a legacy of innovation, resilience, and strategic brilliance that would echo through generations of warfare.